Here's how the electrons are arranged in shells for the first 20 elements. The circles represent shells and the red dots are going to represent the electrons. Hydrogen is number 1 and it has 1 electron in the first shell. We then move across to helium, element number 2, which has 2 electrons in the first shell. Now we're going to start thinking of these as people. So the mum and the dad are together in their room. They spend a little bit too much time together and they have a kid. So we're going to come across to lithium. So we've got mum and dad in their bedroom, so 2 electrons in the first shell, and they have a kid who's going to go into the bedroom. Coming across, element number 4 is beryllium. Mum and dad are still there, but they've had 2 kids. Now we've got 4 bunk beds in this bedroom, and kids don't like to share. So look how I'm going to fill up these electrons. We're going to move across to element number 5, which is boron, and we have 1, 2, 3 kids in that one. Then we're going to come across to element number 6, which is carbon, and they're going to have 4 kids. So mum and dad are together, 1, 2, 3 and 4. Then we're going to come across to nitrogen, which is the 7th element. They've got 5 kids, but have a look how I do this. We've got 1, 2, 3, 4 kids, but they're bunk beds, so they have to start sharing now. So they start sharing, so the electrons start going in pairs. Then we come across to the next one, which is oxygen. So mum and dad, so 2 electrons in the first shell, 1, 2, 3, 4, they start sharing. Same with the next one, which is fluorine, 1, 2, 3, 4, they start sharing, so 1, 2, 3. So 7 electrons in the outer shell. Then we get to neon, which has a full outer shell, which is 8. So 1, 2 for the mum and dad, 1, 2, 3, 4, and then they all have to share, so 1, 2, 3, 4. Now shell number 2 can only hold up to 8 electrons. So if we need 1 more, which is for sodium, we have to bring in another bedroom. So we're going to bring in another shell. So sodium has what we had before. So the mum and the dad, the 8 kids in the first bedroom. So shell number 2 has 8, but then they go and have 1 more, which is out the top. So this is now called 281. Move across to magnesium, mum and dad, 8 kids, so 8 electrons in the next shell, and then 1 and 2. So just like before, they don't like each other, they start moving apart. So the next one, we have the 8 kids in the first shell, or the second shell I should say, and then they have 3 extra ones, so this is 3 electrons in the third shell, and so on and so forth. So we're going to quickly fill in the rest of these so you can start to see a pattern. So the 8 electrons in the second shell, and then this one here is going to be silicon, so it's going to have 4 electrons in the third shell. Next one, still got our 8. We have our 4, but then we have 5 because we're going to bring in phosphorus as element number 15. So they have to start sharing. Electrons start hanging out in pairs. So we've got 8. 1, 2, 3, 4, 5, 6. You should start to be able to see a pattern now if we start to look vertically. If you look vertically, if I can get this in alignment and some description, there we are. If you look vertically, so I'm going to now do this one. So we're up to now chlorine. So chlorine is going to have 7 electrons in its outside shell. 2, 3, 4, 5, 6, 7. Just like the one above it also has 7. Moving along to element 18, which is argon. It has also a full out of shell, which is 8. So we've got 8 in this one. Now, for VCE, you're going to learn that the third shell is a bit more complicated than middle school, but for middle school we say the third shell can hold a maximum of 8. So we now need to bring in potassium, number 19. So our 19th electron needs to go into the fourth shell. So we're going to fill up all the ones before, so 2, 8, 8. So 2, 8, 8, and then 1. Look, the one above it also has 1. Then the last one we're going to be doing, the 20th element, which is calcium, has 2, 8, 8, 2. 2, 8, 8, 2. Just like the one above it also has 2. Okay, now have a look at the blue numbers. These represent what we call the electron configurations. I want you to look at lithium, element number 3, with the 2, 1. Each number you've written down is a shell. So that means there's 2 electrons in the first shell, and you put a comma to represent the next one, so 1 electron in the next shell. Going across to beryllium, element number 4, it has 2, 2. So 2 electrons in the first shell, 2 electrons in the second, all the way across that period, which I'm going to mention in a minute. They're the horizontal rows. It's got 2, 8. Coming down, we've got sodium, which is element number 11. We say its electron configuration is 2, 8, 1. 2 electrons in the first shell, 8 in the next, 1 in the third shell. Now the red numbers that have appeared are representing the groups. They're the vertical columns. So if you look at the first column that I've put a 1 above, that's called group number 1. All of those elements all have 1 electron in their outside shell. That's called a valence shell. Look, group 2, they've all got 2 electrons. Mysteriously, it's suddenly called group 13, not group 3. That's because this version of the periodic table has missed the 10 elements in the middle that we call the transition elements. Then group 14, they all have 4, 15 all have 5, 16 all have 6, and so on. 18 all have 8 electrons in their outside shell. So groups are the vertical columns, and elements within the same group have the same number of electrons in their outside shell. This means they're actually going to behave chemically very similarly to each other. Now have a look at the numbers that have appeared on the left-hand side, the 1, 2, 3 and 4. These represent the periods or the horizontal rows. Periods represent the number of shells that have electrons in them, or the number of occupied electron shells. So period number 1 only has 2 elements, hydrogen and helium, because they're the only ones that have electrons in one shell. Going down, you've got period number 2 has 8 elements in it, because they're all the ones that have electrons in 2 different shells. Elements in period 3, from sodium onwards, have electrons in 3 shells, and the last 2 we've done, potassium and calcium, are in period 4. They have electrons in 4 different shells. Although there are only 18 groups of the periodic table, there are 7 periods, but for middle school purposes we only look at the first 4. So the number of, when we look at an electron configuration, the different number of numbers you've written down represents the period number. So I'm going to look at element 281, which is sodium. You've written down 3 different numbers, 2, 8 and 1, so it's in period 3. The last number you write down represents the group number. So in this case, this is group number 1. Now this does work for groups number 1 and 2. It doesn't really work for the others. You have to add 10, but I'm sure you boys are able to do that.